You open Uber, you tap request ride, and within 10 seconds, sometimes even faster, a driver is on their way to you. Ride confirmed. Okay, but think about this for a second. At that exact moment, there are maybe 500 of drivers moving around your city. Yes or no? And all of them are at different location. Plus, most importantly, all of them updating their position every few seconds. Okay, so let's say suppose this driver, okay, so after few seconds this driver appears to be here, here, or somewhere else. Yes or no? Just like it happens in actual Uber, Ola, whatever. Yes. Now just a few questions for you. How does Uber instantly know which driver is closest to you? And how does it handles millions of users, let's say user 1, user 2, user 3. So millions of users are, booking the cab, requesting a ride. So how does it handles millions of users doing this at the same time? The answer is not what most people think. It's not a simple database query. And today I'm going to show you exactly how it works. And we are going to build it together using Spring Boot plus Redis. Okay, so using Spring Boot plus Redis plus, okay, so these two are most important technologies, plus with HLD, okay, high level design, okay, LLD, HLD. And yeah, so those who are preparing for system design interview, kindly pay attention, stay focused. Okay, fine. So let's start, let's go. So let's understand the actual problem. Okay, imagine your city, and right now there are let's say 500 Uber drivers driving around. Okay, yeah, and every single, just pay attention, stay focused, every single driver's phone sending their GPS location, sending their GPS location to the Uber's backend. Yeah, got it. Every 3 second, every 3 second, okay, every single drivers, there are 500 drivers, so each driver's phone sending their GPS location to the Uber's backend. Okay, that means there are 500 location updates in every 3 seconds. Yes, yes or no? And in a big city like Mumbai, Bangalore, or New York City, the numbers are in maybe thousands, definitely. Okay, 500 I've considered as minimum. Okay, now this is what we consider from the driver side. Let's consider from the rider side. Okay, so suppose now you want to book a ride, you want to request a ride. Okay, so you open your Uber app. Okay, and this is my what, rider. You open the Uber app and tap on request ride. Fine, that, so you just tap on request ride, there is a button, and that request to the backend. Now important question. Backend needs to answer just one simple and most important question. That is, once someone requested a ride, the question is which, just pay attention, question, which driver is let's say my user is somewhere. Okay, so which driver is closest, one second, which driver is closest to this rider, question mark. Okay, and let me quite highlight this. Yeah, so this is the important question. Okay, yeah, definitely, because suppose my user is here, so there are 2 drivers, 3 drivers. So how many drivers are closest to this rider? The important question. Okay, simple but incredibly hard, at scale, because drivers are not under 100. No, there are more than 300, 500, 1000 drivers. Yes or no? Okay, now what most beginners do? See, first let me ask you a simple question. How you are going to build such backend? Like, this is what the backend we need to build. So how you are going to build? What's your plan? At first, like, this is what the scenario in front of your eyes. uh, there are 500 drivers and sending the location in every 3 seconds to your backend which you're gonna build. And there are multiple millions of users who wants to book a cab, request a ride. Okay, and you have to show, like, your backend have to answer this question: which one is closest to accept this request? Yeah, we can't, like, just show some driver who is around 20-50 kilometers away, right? Less than 5 kilometer range. Yes or no? So how you'll approach? So what most beginners would do is they store the driver location in SQL table, MySQL table. Okay, let's say, like, I'm talking about beginners. Yeah, see, the approach is good, no error, no blunder. But this is only good when we have the drivers less than 100 or max 100. That's why I told you, hard at scale, very hard, incredibly hard at scale. And the script we run as a beginner is this. So as we discussed, like, at the beginning, we will store our driver location in the MySQL table. So it's like create table driver locations. Okay, and driver ID will get the latitude, longitude, timestamp. Okay, and we'll run the query to find the nearby drivers. Which query? Okay, let me just choose my pointer, and yeah, this query. Okay, this one. So this is what the Haversine formula to calculate the distance between two coordinates. Okay, like, you can see this is what arc cos. So we have seen cos theta gives me value. Okay, theta equals, let's take cos on the right hand side, so it becomes arc cos and value gives me the angle. Okay, fine. So this is what, and this is query we usually runs. But it is okay for at max 100 drivers. When the driver exceeds 100, 500, 1000, the query gonna scan each and every record in your table. Your database will die. And in this video, I'm gonna show you the best solution and how Uber does this instantly. Okay, exactly what we are building today in this video together. Okay, till end, please be with me till end. Okay, fine. So this is what the actual problem we have seen. Now let me take you to the architecture view, and then we'll deep dive into the Redis. We'll install it, we'll set up. I'll just show you few commands for the Geospatial, and then we'll go forward with our coding part. Okay, so next big thing, next important thing, that is architecture. Fine, and let me walk you through each components. Okay, important, pay attention here. Fine, so let me just select my pen, and yeah, we are good to go. So the first is just focus here. Okay, I'll explain you each and every component, why we are using it, that too. Okay, this is the one. Okay, and here comes our the fastest database. Okay, and this is for the Kafka. Okay, consumer consumes, fine. Okay, so the first is API gateway. Okay, the second one is the location service, then matching service. Okay, then ride service, okay. So these all are my drivers and rider. Okay, and here, okay, so these two I'll fill later on. Okay, once we'll go forward in the architecture. Fine, so let's take one by one. The first is the API gateway. Every request from the driver or from the rider comes through here, nothing talks to our services directly. Okay, so we have did so many projects and we have used API gateway in each one of them. Okay, so we are quite good familiar with that API gateway. Okay, so every request comes through API gateway. Okay, nothing talks to our services directly. Fine. The next service is our location service. So this is the service that every driver's phone talks to and send the location, latitude, longitude, driver ID every 3 seconds. This service is responsible. Okay, fine. Now you might be thinking, okay, so driver phone is sending the location, but where that location, latitude, longitude, driver ID is gonna stored, where those data going to store. Okay, so that is what comes here. Fine, nothing much, magic. It is Redis. Okay, and yeah, geospatial, it is used for that. And why Redis is the best? Why Redis is the best? Because this is my secret weapon. It has inbuilt data structure called geospatial index. Geospatial index. It is specifically designed to store location and find nearby points instantly. No full table scan, no complex query, just one command and you'll get the nearest driver in milliseconds. That is why I called it as a secret weapon and why Redis is the best, only best. Okay, fine, let's come to our next service, matching service. Okay, so first let's see the ride service. Ride service is responsible to publish the requested ride to Kafka. Yes, and matching service consume that event. Okay, so Kafka and Ride.Requested. Yes, let's start visualizing the flow. Okay, fine, just be with me. Driver opens the phone. Location service start receiving the driver location details every 3 seconds. Okay, now rider opens the phone and tap on request ride. Ride service publishes the requested ride events to Kafka. Okay, done. Then matching service. So matching service consume that event. Okay, and it calls location service. Yeah, because location service is responsible to collect the driver location. So it calls and process to find the drivers, best drivers within 5 kilometers, nearby drivers. Also we need to write the algorithm in that way that our algorithm should able to find the best driver. That means not even the nearest driver, but he should have good acceptance rate, good rating, and obviously the nearest one within 5 kilometers of range. Okay, so we'll write the algorithm in that way. Okay, and then matching service pick the best one, assigns, and yeah, done. Yeah, assign the ride and it's done. Enjoy the ride. Yes, and this is exactly the real ride sharing platform like Uber and other platform works at their core. And we are going to build every single piece of it today. Fine, so I hope you got the architecture completely. Okay, got the flow. Now let's go to our Redis part. Okay, let's complete it, set it up, and I'll show you few commands. Okay, pay attention there, and then full coding. Okay, we'll deep dive into the our coding part. Good project, right? Good going. Okay, so let's start our next, that is the Redis part. So we are going to run and connect to Redis CLI via Docker. So make sure you have Docker desktop installed on your machine. If not, no worries. Just go to your favorite browser and type Docker download. Okay, and click on this very first link. Fine, super easy to download, and yeah, just choose your OS, just download it and install it. Keep it ready, open. Okay, fine. Yeah, so it looks like this. Now let me open my git bash. Okay, same, you can download in the same way. Okay, and yeah, this is my terminal, and let me just hit the command. Okay, fine. Yeah, okay, so it's like docker run -d and name, let's say Redis Geo. Okay, port, so 6379 and 6379, Redis latest. Yeah, okay, so unable to find image locally, and now he is pulling from library Redis, right? So let him download, and then we will connect to the Redis CLI. Fine, and then we will see the raw Redis commands. No Spring Boot, no Java, pure Redis. Okay, yeah, so can you see it's up and running here? Docker, there is one container. Just now we are just pulled, and it is running. The name is Redis Geo, what we've given right now. Okay, so now let me connect to Redis CLI. Okay, just follow me and try to code with me parallelly. Okay, the best approach. Docker, okay, and -it what Redis, the name is Redis Geo and Redis CLI. Yes, okay, yeah, can you see this one 127.0.0.1 and colon 6379? That means we are successfully connected to the Redis. Now I told you, no Spring Boot, no Java, pure raw Redis commands. Let's start. Perfect. So the first command you need to know is GEOADD, is used to store the locations. Yeah, let's go. GEOADD, GEOADD, and let me just write, enter the key. Okay, so the key name I'm putting as drivers. Okay, key just like collection of drivers, all drivers. Okay, like I'm calling it drivers all, and then we'll pass the what, latitude longitude. Okay, so let's say 77.5946. Okay, and 12 point, let's say 9716. Fine, and then for driver 1, right, driver 1, that's it, done. Let me just hit the enter. Okay, can you see integer 1? That means the coordinates successfully stored in our Redis. Okay, well, these coordinates are of Bangalore. Okay, fine, I knew it. Okay, fine. So similarly, let's add few more and then find the nearest drivers. Okay, so let's say driver 2, and so 59, and let's say 5800, and 97, so 9800. Okay, fine. Yeah, integer 1 stored in the Redis. Okay, same thing, let me add two more. So this is for driver 3. So these are the different driver location, and they are sending their like their phone are sending their location, latitude, longitude to our location service, and we are storing into the Redis. Okay, fine. So 58, let's say 61, and 98, 96, right? Driver 3. Fine. Let me add one more. So 4 drivers. Let me take 55 and 99. Driver 4. Okay, let me take one more. 5 drivers, right? And here let's say oops, so I came out, no worries. Okay, so driver 5 and let's take 65 and 92. Okay, done. Yeah, done. So we have stored 5 drivers. There are 5 drivers in our city, just moving around. Now I have 5 drivers and their GPS coordinates stored in our Redis. Okay, all in one data structure, that is drivers. Okay, this drivers. Fine, we'll use it. Now the magic command. What makes Redis special? Okay, that is our geo search. Geo search, as the name indicating, search. So it's like a query. We will enter from driver 1. Okay, we will just provide the in the 5 km range, and it'll take it and then gives us the output. Okay, fine. So geo search drivers, okay, key, and member from member, let's say from driver 1. Okay, driver 1, and by radius 5 kilometers. Okay, then in ascending order ASC, and I want the top 3, count 3. Okay, that's it. So geo search drivers from member from driver 1 by radius 5 km in range, ascending order, count 3. Yeah, done. Instantly sorted by distance. No SQL, no table, full table scan, no Haversine formula that we've used to calculate the distance, nearby distance. Okay, I've shown you in the PowerPoint presentation. Okay, the query, big query, select star from, okay, arc of cos, radians, and all that. Nothing. Okay, now also let me show you one more interesting command that gives you the actual distance between 2 points. Okay, that is GEODIST. Okay, drivers, fine, and 2 points. Driver 1, driver 2. Driver 1, driver 2 kilometers. 1.83 kilometers, 1.8374 kilometers, exact distance instantly. One command. Okay, one more. Interesting, right? If you want the exact coordinates of a driver, GEOPOS. Okay, drivers and driver 1. Yeah, can you see the exact coordinates? 77.59459823369998 and 12.97159902243186. The exact coordinates. Yes or no? One command instantly. This is why the Redis is so powerful in Uber use case, because so what we discussed, that every 3 second driver is sending the location. So every 3 second when driver moves, okay, when driver moves, suppose this is our driver. Okay, so every 3 seconds, 0, 3 second. Okay, here. So we'll just run this command GEOADD with the different coordinates, okay, and with the same ID. Then every 3 second, every 3 second, every 3 second. So in this way, we're going to store our all the 500 or 1000 drivers in the Redis, and Redis is able to find out instantly with just one command the nearest and best driver. Okay, fine. See, no Spring Boot till here, no Java, pure raw Redis commands. Now we are going to code our backend Spring, okay, the algorithm. So please don't shift your focus. And yeah, one more thing, if you haven't subscribed, then please subscribe my channel. It really motivates me a lot to create such great videos. Also, if you want, then you can just hit the like button, okay, and comment down. Please comment down, okay, because your comments are really important to me. Fine, okay, so that's it. Let's go forward and let's complete our the last part, okay, the important part, the biggest part. Okay, yeah, let's proceed. Okay, so now let's start with the data flow. Okay, so first, always remember, you need to start with only with the data flow. Okay, what that means, that means is so we actually need total 4 things. Okay, the first is Redis database, which is already up and running, we have covered in the past section. Okay, and why we need it? To store the driver's location. Okay, second thing we need is MySQL database is up and running. Okay, for the ride service, ride storage data. Okay, third thing we need is Zookeeper used by Kafka. Okay, fourth thing we need is Kafka. Okay, for the event streaming. So all these 4 things should be up and running before we get into the coding part. That is the golden rule. Okay, fine. So let me just erase these all, and the Redis is already up and running, so we need 3 things. MySQL also I have already installed in my local. Okay, and now we need 2 things, Kafka and Zookeeper. Okay, so for that, let me go to my file explorer. Already created one folder, Uber app. Let me go inside it, and I have created a Docker Compose file. Let me just open it. Yeah, so in that I have added 4 services: Redis for the driver location storage, MySQL for driver write data storage, Zookeeper, and Kafka. Okay, now just let me open my bash, open git bash here. Okay, and we need to just run one command to let all the 4 services up and running via Docker Compose. Okay, now yeah, just pay attention here. One thing I wanna just show you. So yeah, Docker Compose up -d, and where is my Zookeeper? Okay, Zookeeper, fine, and Kafka, right? So yeah, Kafka name is Kafka, paste it here. Fine, so now I need just 2 things. Why? Because Redis is already up and running. Okay, MySQL I already installed on my local machine. Okay, so I just need Zookeeper and Kafka to start, create, and run it. Okay, so I hit the enter, and can you see Kafka and Zookeeper is pulling. Okay, let them pull, let them start, let them create the container. Kafka is also almost completed. Yeah, okay, let's wait for a few more seconds. Let them create the container and start it. Okay, so yeah, let me put this side by side. Okay. Okay, so can you see the network Uber app ride share network created, and these 2 containers, container Zookeeper and Kafka, created and started. So yeah, so this is our Redis, and this is what our Uber app, and Zookeeper and Kafka is up and running. Fine, so 1 2 3 and MySQL already installed in my local. Okay, so now this is what our data flow completed. Now we'll go to our Spring Boot, set up the project and start coding. Okay, fine. So first you need to always start with the data flow. Okay, Yeah, so here I'll just put all the services, location service, matching right service. Okay, let me just go to my browser and create all of them. Okay, so let's go to our browser and hit Spring Initializer, start.spring.io. Okay, project Maven, language Java, Spring Boot version, and here com dot, let's say, ride share. Okay, and location. So first our location service. Yeah, packaging name this. Okay, fine. Packaging, configuration, Java, everything looks good. Now let's add the dependency. So the first is web, then Redis. Okay, Spring Data, Redis, then Lombok. Okay, then actuator. Okay, yeah. So for the location service, that's it. Yeah, for now, let me just check it. Actuator, Spring Boot, starter, data, Redis, and web Lombok. Yeah, let me. Okay, so let's save it. Location service is done. Now the next is ride service or matching service. Yes. Okay, so matching service, let me remove this and add the Kafka. Okay, Spring for Apache Kafka, rest all is good. Okay, and further if we need any more dependency, then we'll add it externally via MVN repository. Okay, for now let me generate it. Matching service. Oh, 1 second. Yeah, matching service, let me generate it and save. Okay, similarly write service. Okay, so in the write service, in case what I need MySQL also. Okay, and JPA, yes, and validation. Yeah, so Kafka, MySQL, JP validation. Okay, let me generate it. Write service, save. Okay, so let me go to my file explorer and Uber app. Here all our services, let me extract it, extract all. Location service done. Then okay, so you can see here is my code editor, IntelliJ IDE, and I imported all the services, location service, matching service, and write service. Fine, so let's start with our location service. Okay, so yeah, so as we discussed that location service is responsible for what? Driver's phone sending the location GPS coordinates, and our this service receives it stored in the Redis. Okay, so let's go first with the DTO. Our first DTO, let's say driver location request. Okay, yeah, driver location request. So this DTO is going to receive the data. What data? GPS coordinates. Okay, so private string and driver ID. Okay, then private double latitude. Okay, and then private double longitude. Yes. Okay, at data and at all args, at no args constructor. Fine, one more DTO class, let me just create it, that is driver, or I can just say nearby driver response, nearby driver response. Okay, so this is going to send out data to the our matching service. Okay, so this is what my let's say location service, and this is my matching service. Fine, responsible to match and assigns. Okay, so just like less than 5 kilometer and everything else. So driver D1, D2 and so on D500. So driver sending the location GPS coordinates and sends internally the location coordinates and also distance in kilometers to the matching service. Yes, okay, so that our matching service got to know the data and also the distance in kilometer and assigns the proper appropriate driver. Okay, assigns the ride. Okay, so let's, and that is why let me just put it here, copy this. Okay, and one more field, that is private double distance in kilometer. Okay, we need to, because this DTO is responsible to send out data to the matching service, so we need to send the distance also in kilometers. Okay, and this all remains same. Okay, fine. So now let's build complete skeleton. Okay, controller dot location controller. Okay, and service dot location service. Okay, and configuration. So config dot redis config. Okay, location controller at rest controller at request mapping API v1 locations at slf4j. Okay, let me also private final location service. Okay, at required args constructor. Yeah, let's code our endpoints. Okay, so now what all methods we need to create, what all endpoints, that is an interesting story. Okay, let me just take my pen and you have to answer. Okay, so this is my rider, this is my suppose rider phone. Okay, rider. Okay, here are our थोड़ा गलत बन गया. Here are our drivers. Okay, D1, D2, D3 and D500, all are on the different location moving around. Okay, and this is my location service. Okay, so now what all endpoints we need to create, that is another interesting thing, interesting story. Let me just select my pen and you have to answer me that. Okay, so let me take rider, this is my, let's say, rider's phone. Okay, and okay, he wants to request a ride. Here are our drivers D1, D2, D3 and D500. Drivers are moving around. Here our location service, here our matching service, and here our ride service. Okay, so now drivers sending their location updates every 3 seconds. So we need to create first method, we need to create a method which is responsible to get the driver, okay, driver location, and every 3 seconds updates it with their ID. Like D1 is here, after 3 seconds D1 is here, after 3 seconds D1 is here. So with that ID uh, should update that driver location. Yeah, okay. So first method, that. Good. Second method, now rider request a ride. Okay, control comes here. Fine. Now ride service calls the matching service. Wanna match, this is the middleman, match the proper driver. Okay, and matching service calls this location service to get the data, this data, which driver is nearby. Okay, so second method is to get the nearby drivers. Okay, nearby drivers, fine. Yeah, nearby drivers, the d1, d2, d3, whatever. Okay, now third method, when driver goes offline, so in that case we'll remove the driver. Okay, so these are three methods. Okay, and also we need to just do the Redis configuration plus the flow, the sequence, latitude, longitude, and go on. Okay, so let's proceed. Fine. So public and response entity string, and get and update the driver, or just update driver location. Okay, at request body, and we have the DTO, driver location request, driver location request. Okay. And it is post mapping. Fine. Drivers update. Okay, let me also put the comment. So calls, or driver phone calls this every 3 seconds. Yeah, so driver phone is sending the location, that means it calls this every 3 seconds, so that will update the driver location based on their ID. Okay, and it contains the driver ID and all the data. Location service dot update driver location. Okay, we'll create this method in the service, and let me pass this request, return response entity dot. Okay, fine. And internally we'll just set a message like driver location updated. Okay, that's it. Yeah, so this is our first method. Now the second method is to get the nearby drivers. Okay, fine. The next is public and response entity list, response entity and list. Okay, because there are list of drivers nearby. Yeah, definitely multiple drivers we'll see in the Uber application. Okay, once we'll just wanna request a ride. So list of what? Nearby driver response and get nearby drivers. Okay, in that we'll pass at request param, and what is double double latitude. Okay, and then at request param double longitude, and add radius. Okay, so add request param, let me just set the default value, let's say 5. Okay, and double radius. Okay, yeah, fine. Okay. And return location response entity dot okay location service dot find nearby drivers. Okay, and we'll pass the latitude, longitude and radius. Okay, get mapping drivers nearby. Okay, and let me just add the comments as so matching service, right? Matching service calls this when ride is requested. Fine. Now the third one, that is when driver goes offline. So when driver goes offline, public response entity of string and remove driver by driver ID at path variable. Okay, and a string driver ID. Fine. Location service dot remove driver and driver ID, return response entity dot okay driver removed. Okay, successfully. At delete mapping drivers and driver ID. Okay, that's it, done. Yeah, so let's implement these methods. Okay, then Redis config and then move to the next service, and yeah, application.yml and then next service. Okay, okay, all of you please pay attention. Okay, because in this section we are going to build the functionality. So service and add service. Fine, add slf4j. Yeah, okay. So now at first let me declare the keys. Okay, the keys like as we have seen this driver key when we saw the raw Redis commands. Okay, so this is the key we have just created GEOADD drivers and we have passed the coordinates. So here is the key, we need to create it in the backend. So private static final and a string drivers, let's say geo key, and so we have given the drivers, right? Or we can just drivers locations. Yeah, more readable. Yes, okay, let me also add the comment Redis key for all driver location. Okay, yeah, fine. So now let me also add one comment, update driver location in Redis. Okay, and call every 3 seconds by driver's phone and maps to Redis GEOADD command. Okay, that is only the command we have seen. So yeah, GEOADD. Okay, to add and update the driver coordinates location. Yeah, so our first method, that is update driver location. Okay, let's implement it. Public void and update driver location. I'm getting what? The driver location request. Okay, fine. So at first let me add some loggings, log.info, and updating location for driver, and let me get the ID. Okay, ID from the driver request dot get driver ID. Yes, okay. Now what? 1 second. Okay, now yeah, okay, so I'll just show you one thing. Let me just get the point. Okay, yeah, org spring framework data dot geo. Okay, and driver point equals new point. Okay, and in that I need to pass the coordinates, longitude and latitude. Okay, yeah, so first let's say driver request dot get latitude. Okay, and driver request dot get longitude, and this. But here is a big mistake I have committed. So important, remember longitude first. Okay, and latitude second. Yes, why? Geospatial standard. Okay, so let me just copy this. Okay, driver dot get latitude. Fine, so longitude first and latitude second. Okay, now let me add it. Okay, and for that let me just get the private final and Redis template. Okay, Redis template and string. Okay, at required args constructor. Okay, Redis template. So now Redis template dot ops for geo. Okay, then we need to add it. Okay, and what we need to add first, we need to just pass the key. So this is the key. Then what? This driver point. Okay, and then driver ID. Okay, driver ID. So driver ID, and that's it. What is this method, ops for geo? Okay, so see, this method gives us access to all Redis geospatial commands. This method is, gives us access to all Redis geospatial commands in Java. Whatever we have used in the raw Redis commands. Okay, so yeah, GEOADD, GeoRadius, GeoSearch, GEOPOS. Okay, everything, every command goes through this method. Every command. Okay, yeah, fine, and that's it. So it is going to get and update the driver location. Here is the key, here is the latitude, longitude we are passing, and this is the driver ID. So based on the ID, it is going to update its location. And fine, d1, then d1 here, then d1 here, d1. Okay, I hope you got it. And then nothing else, so let me also add one more logging, log dot info, and location updated for driver, and driver request dot get driver ID. Yeah, okay, so this is our first method implementation. Now the second method, that is find nearby drivers. So let me just add the comments, find nearby drivers within given radius, okay, and called by matching service on ride request, okay, and maps to Redis geo radius command. Okay, fine, let's go public list. Okay, need to return the list of nearby, what's the DTO, nearby driver response, and the method name is find by nearby drivers. Okay, and I'm getting what, double latitude, then double longitude, double radius. Let me just write radius in kilometer. Okay, it is better. Okay, fine, yeah. So first log dot info, and finding drivers near lat, okay, long, within kilometer, okay, and latitude, longitude, radius in kilometers. Okay, then we'll just get the circle. Okay, so org spring framework data geo. Okay, search area, we need to create a search area. Okay, equals new circle, and we need to just get new point in that longitude and then latitude, right? The second thing is distance, new distance. So let me just pass the radius, okay, like suppose minimum 5 kilometers. Okay, so radius in kilometers, and metrics dot kilometers. Okay, done, created the search area. Okay, now we need to get the results. Okay, what all drivers are in this search area within the radius and latitude, longitude. Okay, so for that, geo results, okay, and Redis geo command dot geo location. Okay, so Redis geo commands, and yeah, connection 1 dot geolocation and string, right? And I need the results, equals Redis template dot, and yeah, ops for geo, same method. Okay, all command goes through this method. Okay, now dot radius, okay, and let me just pass the key drivers geo key, okay, and then the search area, okay, and then Redis geo commands dot geo radius command args dot new geo radius arg, okay, dot I need to include the first coordinates, then I need to include the distance, and then I need to sort them via ascending, and limit, let's say max 10, okay. So just like we have hit that command here in the raw Redis geo search drivers, this is the key, okay, this is the key, here is this is our key, okay. Then from member driver 1 by radius 5 kilometers, ascending order count 3, okay. Same thing, include coordinates, distance, ascending order, and limit 10, let's say, okay. Then need to just create a list of, need to return nearby, and nearby drivers equals, let's say, new array list, okay. If now if results, okay, if results not equals null, okay, that means we got some drivers, yeah. So results dot get content dot for each, okay, and in that result, okay, geo result, yeah. So Redis geo commands dot geolocation, okay, of type string and location, so we'll get it from the result dot get content, okay. Here what I'm getting, okay. And now what, nearby drivers, okay, dot add, and new, so need to just return what, location dot get name, okay, and then location dot get point, right, get point, and we need the y-axis, right, get y-axis, then location dot get x-axis, okay. So get point dot get x, okay. Then result dot get distance dot get value, okay, fine. Then log dot info found drivers nearby, okay. So nearby drivers dot size, okay. Now let me explain this. So results, okay, results dot get content, that means we are getting the list of drivers. On that list we are applying for each loop, okay, that means one driver, fine. Then we'll get the location details, and then we are fetching what, like in the location we are getting the everything, the first location details and IDs, okay. So from that we'll get this get name, so in the get name we are getting the ID, then get y-axis, get x-axis, okay, latitude, longitude, and this is the get distance, exact distance from the rider in kilometers. Okay, yeah, and then finish it. Okay, fine. And then we'll return nearby drivers. Yes, nearby drivers, that's what we need to return, list. Okay, so this is what the entire implementation, how to find the nearby drivers within given radius. Okay, so now quickly let's move to the next part, that is remove driver when they go offline and maps to Redis ZREM command, right? Okay, so our third method which remove driver. So nothing much, public void remove driver, and I'm getting the driver ID. Okay, so first log.info, and I'm removing driver. Okay, so driver ID, and then Redis template dot same method. Okay, all the commands goes through it, dot remove, see it's automatically populating, and need to pass first the key, so drivers geo key and simple driver ID. Okay, so remove by ID. So this is what our entire implementation, all the methods got implemented. Yes, okay, so now let's do the Redis configuration. So it's nothing but we need to just create the bean of REST template and make the data human readable in Redis CLI and return it. Okay, so add configuration. Okay, so public Redis template and a string Redis template. Okay, and we need to just pass the Redis connection factory and let's say connection factory. Okay, so first let me get the object of REST template. Okay, and a string template equals new Redis, oh sorry, my bad, it's Redis template. Okay, Redis template, fine. Okay, and then let me template dot set connection factory. Okay, and then a string serializers make data human readable in Redis CLI. Okay, so template dot set key serializer. Okay, and new string Redis serializer, fine. Second template dot set value serializer, new string Redis serializer. Third is template dot set hash key serializer, new string Redis serializer, and the last one is template set hash value serializer, and string Redis serializer, return template. Okay, and yeah, important thing, bean. Okay, so this is what our 90% job is done. The last thing is resources, application.properties or YML, whichever you are good in. Let's go with the properties. Okay, so application properties first. Okay, spring dot application dot name, so location service. Okay, and server dot port, so 8082. Yeah, no doubt, right? Now Redis configuration, Redis configuration, so spring dot data dot redis dot host, so local host. Okay, and spring dot data dot redis dot port, so 6379. Okay, 6379. Yeah, okay. And the last is actuator configuration. Okay, so management dot endpoints dot web dot exposure dot include equals health and info. Okay, so let's start with the write service. Okay, and then matching service. Fine. So why write service? Because just now we have completed our location service. Fine, that means driver is sending the location. Okay, now the next is rider part, that is the ride service. Okay, and then at last we'll complete our final matching service. Okay, final thing. Okay, so just let me close all the tabs. Okay, and let's start with our write service. So write service is quite, somewhat contains more number of endpoints, and also contains the Kafka configuration. Okay, global exception handler, controller, DTOs, events, models, repository, and the service class. So let's start fresh model dot write. Okay, done. So yeah, first private string id. Okay, and then we'll take the rider id. Okay, and then we'll take the driver id. Okay, driver id. Fine, and then we'll take the pickup location. Okay, pickup location coordinates, so private double, and then pickup latitude. Okay, similarly pickup longitude, so private double and pickup longitude. Then we'll just add a field for pickup address. Okay, so private and a string pickup address. Okay, fine, and then drop location, so same thing, private double drop latitude, and private double drop longitude, and then the same string private string drop address. Okay, and then the status, that is what and then the status, ride status. So for that we'll create the enum. Okay, private ride status. Okay, status we'll create it after we'll complete our entity. Okay, and then what, the fare details. Okay, so let me just add comments here, ride status. Okay, and so it tracks the life cycle. Okay, then what, so then fare details. Okay, and private double estimated fare. Okay, and private double actual fare. Okay, then yeah, timestamp, so time stamps. Okay, So timestamp fields are private, local date, time, and created at. Okay, same thing, private, local date, time, and updated at. Fine. And also we need to add the timestamp for the time where the trip started and completed at. Okay, so private, local date, time started at, and private, local date, time completed at. Okay, yeah. So now let's add some Lombok and validation. So entity and table name, let's say rides, and then add data. Okay, then no arcs, all arcs. Okay, fine. So now add id. Okay, and add generated identity. Here also let me add some comment that rider who requested the ride. Okay, and some validation at column nullable false. Okay, here too some comments who accepted the ride. Okay, and so let's keep it null until matched. Okay, yeah. So at column nullable false. Okay, then the same thing, let me just copy and paste here. Nullable false, pick up latitude, pick up longitude, and address too. Fine. Then same thing for the drop longitude. Okay, latitude, longitude, pick drop address. Oops, drop address. Then for ride status, so let me create it in the model itself, new. Okay, and enum ride status. Okay, so status, fine. Let me also just add some comments. First let me add the flow. Okay, the flow is like requested, ride requested. Okay, so then matching. Okay, then accepted. Okay, and then driver arriving. Okay, then ride started. Okay, the status changes to ride started. Okay, and then completed. Fine. Or cancelled. Okay, like can happen at multiple stages. Yes, so like starting the flow is like matching initially, ride requested matching. So first is requested, then matching. Okay, so yeah, these are only the status. Okay, the flow is only the status, like requested. Okay, so requested, then matching. Okay, so another status can be matching, then accepted. So accepted, then once accepted, driver arriving. Okay, driver arriving, so arrived, and then ride started, another status, and ride completed. Okay, and then the cancelled status. Okay, like it can happen at multiple stages. Fine. Okay, okay, go back here, and so at enum. Okay, string, and column nullable false. Yes, the timestamp at creation timestamp, and at update time stamp. Okay, fine. So yeah, that's it. Okay, that's it. Oh, 1 second. All args constructor. Yeah. So now next is let's add our DTOs. Okay. Oh, 1 second. Not a class. It should be package. So DTO dot so ride request. Okay, our first DTO is ride request. Fine. Okay, as the name indicating, ride request. So it contains private a string rider ID. Okay, rider ID. Then private double pickup latitude. So pickup, 1 second, let me put them side by side. Okay, so that I can just copy to save my time, right? Okay, so then pickup latitude. Okay, private pickup latitude. Okay, then private double pickup longitude. Okay, already populated. Then pickup address. Okay, fine. And then drop, same thing for the drop. Okay, so just let me copy these three. Okay, fine. Yeah, so let me add the validations. Okay. Hmm. Fine, so add not blank and message, let's say rider ID is required. Okay, same thing, let me just copy and paste in all. So it should be not null. Okay, not null. Fine, the same thing. Okay, here let me change the message. Pickup latitude is required. Pickup latitude is required. Okay, then pickup longitude is required. Okay, then pickup address is required. So pickup address is required. Then drop latitude is required. Fine, same thing, same thing. So drop longitude is required and drop address is required. Okay, yes, fine. Now add data and all args, no args. Okay, done. Next is ride request. So there must be ride response. Ride response. Okay, fine. Yeah. So it means once user request a ride, what response he'll get. So let me just copy from here and let me just take it. Okay, and you just shift little bit. Okay, so fine, let me just remove all the validations, right? And okay, so we already done, right? Okay, so ID, rider driver ID, pickup latitude longitude address. Okay, drop latitude, longitude, address, and status estimated fare. Okay, estimated fare, where is that? Estimated fare, fine. Actual fare and created, updated, started. Okay, fine. All fields I need I'm getting in the response. Okay, just okay. And where is my, let me just, oh oops, copy and paste. Okay, done. Now that's it, our DTO is done. Ride request, ride response. Now let me create controller dot ride controller. Okay, ride controller, and also let me just create service dot ride service. Okay, then what is repository. Okay, interface dot ride repository. Okay, extends JPA repository, so ride and long. Yeah, and the last one is Kafka configuration, so config dot Kafka config. Yes or no? Okay, also let me just create global exception handler. Global exception handler. Yes, done all. So service repository, and yeah, also one more thing, event dot ride requested and event. Now I guess everything is done, so let's start with our ride controller. Okay, so REST controller request mapping. Okay, API v1, API v1 and rides. Okay, fine. Also SLF4j. So now let me just private final and ride service. Okay, at required args constructor. Okay, so our first endpoint is when rider requests a new ride. Okay, so rider a new ride. Okay, and public response entity of we want ride response in return. Okay, and the method name is request ride. Okay, so this method called when rider request a ride. Okay, so add valid. Okay, and add request body ride request. Perfect. Now also let me just, okay, now first let me add some loggings, log.info and ride request received from rider. Okay, and the rider ID, so ride request dot okay, ride request dot get rider ID. Okay, and then in return response entity dot status and http status. Okay, where is that? http status dot created. Okay, and dot body ride service dot request ride. Okay, we'll create this method implementation and we'll pass this ride request here. Yes or no? Yes. Okay, post mapping. Okay, and request. Fine. Next endpoint. So public response entity. Okay, and ride response, then get ride by id. Okay, and I will pass path variable, and it should be string ride id. Okay, and quickly let me just return response entity dot okay ride service dot get ride by id, and let me pass the ride id. Okay, get mapping and rider ride id. Yes. Okay, next is let's get all the rides for a rider. Okay, quickly, and then we'll go to the driver side. Public response entity of list. Okay, all the rides. Okay, so list of ride response and get rides by rider. So add path variable, and same thing, string, here it should be rider id. Okay, not ride id, rider id. Okay, and then return response entity dot okay and ride service dot get rides by rider. Okay, this method will implement it, and will pass the rider id here. Okay, this to get mapping and rider. Okay, 1 second. So no, it should be, let's say, ride id. Okay, and here, okay, rider, and then rider id. Yeah, this is fine. Okay, done. Now the next method is driver starts the ride. Okay, so driver starts the ride. Fine. Public response entity and ride response. Fine. Start ride. So add path variable and string ride id. Okay, start the ride, so ride id, and return response entity dot okay ride service dot start ride, and we'll pass the ride id. Okay, here it should be what? Put mapping, and so ride id and start. Okay, fine. The next is when driver completes the ride. So public response entity, okay, and ride response complete ride. Okay, same thing, at path variable and ride id, then return. So let me just copy and paste this and change the method name, complete ride. Okay, rest all is same. Also put mapping, so here it should be complete. Okay, and the last method is cancel. Public response entity, so let me just copy paste the entire response entity, cancel ride. Okay, path variable string ride id, and here cancel ride id, and cancel. Okay, that's it. So these all endpoints, and we need to implement the the implementation. Fine, so let me just go to my ride service and start the implementation. Okay, need to declare the Kafka template and ride requested topic. Okay, as we discussed that in the flow diagram, architecture diagram. Fine, add service, then add slf4j, then add required args constructor. Okay, and first private final ride repository. Okay, we need it. Then private final Kafka template, and string and ride event. Okay, so what's the event name? Ride requested event. Okay, fine, and then Kafka template. Okay, also private static final string ride requested and topic equals ride dot requested. Okay, yeah, so the step 1 is let's create a ride in the DB. Then step 2 is publish ride request event to Kafka, and then step 3 is matching service. Okay, so step 1, create ride in DB with requested status. Okay, let's do it. Public ride response request ride. Okay, and I'm getting the ride request. Okay, fine. Now let me just add some loggings, log.info, and new ride request from rider. Okay, so request dot get rider id. Yeah, and then step 1. Okay, save ride to database. So ride equals new ride, or you can use the at builder here, Okay, so let me just go with the same simple one. Where is my new ride? Okay, and then ride dot set rider id. Okay, then let me do the fast forward. Okay, so I've just completed it. Set pick up all the fields. Okay, and I'm setting the values which is coming from my ride request. Okay, then one more field is remaining, ride dot set estimate fare. Okay, so we need to calculate the estimate fare. Okay, so for that we'll create a method calculate estimate fare, and we'll pass the request. Okay, that's it. Now ride saved ride equals ride repository dot save and ride. Okay, fine. So this is what ride saved. Now our step number 2, that is publish event to Kafka. Okay, and matching service will consume this and find nearest driver. So let me just take this ride request event. Okay, ride request event equals new ride request event. So let me just go to the ride request event, and first let me add some comments like event published to Kafka when a ride is requested. Okay, and matching service consumes this event. Okay, and the topic Ride.Requested. Okay, yes or no? Yes, topic Ride.Requested. Fine. Now let me add few fields here. So private string ride ID. Okay, then private string rider ID. Okay, then pick up and drop. So let me just, where is my DTO? Pick up and drop. Okay, drop and pick up. Fine. So matching service uses this to find the nearest driver. Okay, and this is for fare estimation. Fare, like where is your drop location. So according to that, fare estimation will calculate. Okay, fine, let's go with it. saved ride saved ride dot get ID. Okay, then saved ride, one second, dot get rider ID. Okay, similarly for the pickup and drop. Let me just do the fast forward. Okay, one second, at data at no args at all args. Okay, and then fine, and Kafka template dot, we need to send it. Okay, send, and then the topic is ride requested topic. Okay, and saved ride dot get ID. Okay, and then the this event. Okay, so there the matching service consumes. Okay, let me add some loggings. So ride requested event published to Kafka, okay, for ride and saved ride dot get ID. Okay, and then we need to update it. So update status to matching. Yes, now it is matching. Okay, so saved ride dot set status to matching. Okay, Fine. And then ride repository dot save ride. Okay, see, this is matching requested done, then matching. Okay, and then we will return map to response and saved ride. Okay, because we need to return our ride response, and here we are getting the ride. So let me create this method, and then simple with the builder, or just create an object, set the values, and then done. Okay, okay, so just okay, saved ride. Yeah, so map to response the method, and here ride response a new object, and setting all the values and then returning. Okay, so getting the ride response. Okay, now also need to calculate this method to calculate the estimate fare. Fine, so we'll do it first. Let's implement all the methods. Now we need to create the method, one more method. So it's like public and void update ride with driver. Okay, and I'm expecting ride ID and a string driver ID. Okay, now you all might be thinking that there is no such method by this name update ride with driver in our controller. So why you are creating this? Because the purpose of this method is to update the status. Okay, just see here, um, you know so suppose this is my matching service, okay, and this is my write service. So write service calls the matching service, and matching service is matching. So this is what the status we have just set, write status dot matching. So it is matching, the process is going on. Once some driver accepted the request, that means we need to change the write status from matching to accepted. So this method is called by matching service when a driver is found, and updates the ride status to accepted and assigns the driver ID. Yeah, let that this is the driver. So that is why this method is called by matching service. That is why we need to create this. Okay, so what? Ride equals, okay, so first let me get the ride. So ride repository dot find by id and ride id. Okay, dot or else throw, and new runtime exception that ride not found. Okay, so now let's do it. Set driver id to the driver id. Okay, we need to set it, and ride dot set status to accepted. Okay, accepted, and then let me just update it, ride dot save and ride. Yeah, that's it, done. Okay, so fine, I got it. So ride repository here string. Okay, yeah, done. Okay, now let's go forward with our pending methods. Okay, so let me just start with the start ride. Okay, this get ride by id and get rides by rider, we'll do it later on. First let's implement these important methods. Start ride, I'm getting the ride id. Okay, so public and ride response. Fine, start ride, and I'm getting the string ride id. Okay, Now same thing, so let me first get the ride. Okay, get the ride, and then let me just add few check, like if ride dot get status is not equals accepted. Okay, if not accepted, like if it is in the matching state only, then we need to throw new runtime exception that ride cannot be started. Okay, and current status is ride dot get status. Okay, yeah, else oops else ride dot set status as ride started. Okay, and then ride dot set started at, okay, so started at time, so local date time dot now, okay, at that time, and then let's save it. So ride repository dot save ride. Okay, and then we will return map to response and then ride. Fine. Okay, now next is complete ride. Okay, so public ride response and complete ride. Oops, complete ride. Okay, I'm getting the string ride ID. Fine. Now same thing, first let me get the ride. Okay, and then if the ride status, so here it should be, the checks should be ride started. Okay, ride started, then throw new runtime exception that ride cannot be completed. Current status this. Yes or no? Else let me copy this. Okay, so here we need to set status as completed and set completed at and also yeah, so we need to just, so once ride is completed we need to get the actual fare, set actual fare, so ride dot get estimated fare. Okay, yeah, so we will just calculate it, it's pending. Okay, we'll calculate it, we'll create this method. Fine, and then save it and return map to response, right? Yeah, done. Next method is cancel ride. So public and ride response cancel ride. Okay, I'm getting the string ride ID, and same thing, first let me get it, if ride not found. Okay, then throw the exception, and then else if found, then we need to just set the status as cancelled and ride repository save. Okay, ride repository save the ride and then return map to response, right? Okay, then what else is remaining? So get rides by ID. Can you do this by your own? Huh? Okay, let me just, very simple implementation. So public ride response and get ride by ID, a string ride ID. Okay, so this thing first, ride not found. Okay, and then Yeah, simple thing, map. And for the last method, what's that? Get rides by rider. So public list, okay, public list of ride response, and get rides by rider, a string rider id, rider id. Yeah, rider id. Okay, so here we need to return ride repository dot so we need to create the query method. Let me do it. Okay, so I need the list of ride list, need the list of ride. Okay, and then the method starts like find by rider id. Okay, order by created at and in descending order. Okay, and I'm getting the rider id. Same thing, find by rider id and order by created at. Yes, so where is that? Okay, this, and then let me pass the rider id dot stream dot map. Okay, and this, so map to response dot collect. Okay, collectors dot to list. Okay, done. So everything is done, only one thing remaining, that is to calculate the estimate fare. Okay, yeah, so then let me put it as private double calculate estimate fare, and I'm getting the ride request. Okay, so first we need to calculate the distance. Okay, so simplified using the Haversine formula. Okay, simplified Haversine distance calculation. Okay, so we have the latitude longitude, so double lat 1 equals math dot to radian, math dot to radians, and request dot get pickup latitude. Okay, and then double lat 2 equals, so math dot to radians and get drop latitude. Similarly, double longitude 1 equals math dot get pickup longitude, 1 pickup longitude. Okay, and double, so drop longitude. Yes, fine. So now double latitude difference. Okay, so d latitude equals lat second minus lat 1, and double, so difference in longitude equals long 2 minus longitude 1. Now let me calculate the intermediate value. Okay, so double a equals math dot power math dot sine and difference of latitude by 2. Okay, plus math dot cos of latitude 1 cross math dot cos of latitude 2, and then times math dot power. Okay, and math sine difference of longitude by 2, and yes, okay, and the angle. So double C equals 2 times math dot arc of sine and math sqrt square root of a. Okay, so the distance in kilometers equals 6371 times c. Okay, and the base fare. Okay, so let's say 50 plus 12 per kilometers. So 50, let's say in rupees, right, plus 12 rs in kilometers. Okay, so double fare equals 50 plus how much distance in kilometers cross 12. Okay, and we need to return math dot round fare 100 0 and divided by 100 0. Yeah, so this gives me the fare. Okay, estimated fare. Fine, so I guess everything is done, completed. Okay, where is I'm getting an issue. Okay, rider ID, what's that? Okay, a string. Okay, it's done. Yeah, now it's done. So what else is remaining? Ride controller service, we've implemented all the methods, and now Kafka configuration, yes, global exception handler and application properties. So let's start it. First let me just complete this global exception handler. Okay, rest controller advice and add slf4j. Okay, so now public response entity and map string first we need to handle the validation error. Okay, so method argument validation exception. Okay, ex, and so map string errors equals new hash map. Okay, and exception dot get binding result dot get field errors okay, no errors. Okay, and then let's apply the for each. So errors dot put error dot get field. Okay, and error dot get default message. Yes, and we need to return response entity dot status. So bad request, yes, so bad, and request, no, http status. Okay, dot bad, not gateway, what's happening, bad request, and dot body errors. Okay, here at exception handler and method argument not validation exception dot class, not valid exception dot class. Okay, yeah, the next is to handle the runtime exception. Okay, so only two exceptions will get response entity and map string and handle runtime exception, then runtime exception. Okay, so what first let's add some logging log dot error and runtime exception. Okay, and here dot get message, right? Then let me just copy this. Okay, and errors dot put and error exception dot get message. That's it. Yeah, and then return response entity status bad request body errors, and in the at exception handler, so runtime exception dot class. Okay, yeah, it's done. So our global exception handler also completed. Now let's move to our Kafka config. First configuration. Now so topic where ride service publishes ride request. Okay, and matching services subscribers to this topic. Okay, so for that we need to create the bean public new topic. Okay, and ride requested, let's say ride requested topic. So return topic builder dot name. So what's the name? The name we kept it ride dot requested. Okay, then dot partitions, so 3. Okay, then dot replicas, let's say 1. Okay, dot build. Yes. Okay, let me create the bean, and next is topic where matching service publishes match results. Now for next, where matching service publishes match results. Okay, so ride service subscribers to this topic. Okay, and it's like, so public new topic. Okay, and ride matched topic. Okay, and then we need to return topic builder dot name. So let's say ride dot, we'll create it, okay, in the matching service, ride dot matched dot partitions 3 and replicas 1 dot build. Yes, at bean. So two beans we have created. Topic where write service published write request. Topic where matching service publishes match results. Okay, so everything is done. Now only one thing remaining, that is properties file. Okay, let's do it quickly. Okay, so first properties of our application, spring dot application dot name equals ride service. Okay, then server dot port equals 8083, or I'm not comfortable in it, let me just delete it. Okay, let me recreate the file application dot YAML. Okay, yeah, now it's better. So first application properties, spring dot application dot name write service. Okay, then server dot port, so let's say 8083. Okay, then spring is already there, so inside spring MySQL, so database fields, MySQL we are using database. Okay, so spring dot data source, okay, dot URL, so it's JDBC MySQL and local host 3306. Let me create the DB. Let me open my MySQL command line for that. Okay, let me enter my password and create database Uber app. Okay, query okay, created, fine. So Uber app. Okay, then what URL? So username, root, password, I'll enter it later on. Okay, then what, driver class and name, so com dot mysql dot cj dot jdbc dot driver. Yes, fine. Now okay, jpa. Okay, so spring dot jpa dot hibernate dot ddl auto update, and jpa dot show, one second, show sql true. Okay, and jpa dot properties dot hibernate, oh, one second, hibernate, okay, and dot dialect. So the dialect, let me just go to my search and MySQL dialect. Okay, here let me just org dot, okay, dot MySQL dialect, so dot MySQL dialect. Okay, yeah, that's it. Now Kafka properties, so spring dot Kafka dot bootstrap servers, so local host 9092. Okay, then Kafka dot producer dot key serializer. Okay, so org dot apache dot kafka dot common dot serialization dot string serializer. Okay, yes, key serializer, fine. And Kafka dot producer dot, so it's key. Okay, now value serializer, okay. So org dot spring framework dot Kafka dot support dot serializer dot JSON serializer. Okay, serialization, fine. And then the actuator. Okay, so management dot endpoints dot web dot exposure dot include. Okay, same thing, health and info. Yeah, so this is what our application properties file. And with this our Ride service also fully completed. Configuration, global exception handler, controller, both DTOs, events, models, status, repository and service, where we implemented all the methods. Okay, fine. So now only last thing remaining, that is matching service. Let's do it quickly and then let's test it out. Okay, so let's start with our last, that is matching service. Let me first close all tabs. Yeah, now in the location service, if you remember, we have created DTO, that is first is driver request and the second is nearby driver response. Why this created? We have created this because this is what the response, and the nearby driver response DTO is responsible to send out the data, this data, GPS coordinates, ID and distance in kilometer to our matching service. So we need to create this DTO in the matching service too, to collect that response. Okay, fine. So location service, matching service, main Java, and DTO dot. Okay, and let me also just comment down. Okay, so that you'll get a clear-cut understanding. So response received from location service. Okay, so location service is going to send the data and here we are receiving in the matching service. Okay, when querying for nearby drivers. Okay, so location service, let me just copy and paste this. Okay, done, fine. So we are receiving the response from location service, that's it. Now let's create the event. Okay, so event dot, so there are two event. First is ride requested event. Okay, once a rider requests the ride, and then the second is ride matched event. Okay, fine, requested. Okay, rename it, fine. So in that, okay, so event consumed from Kafka topic, and we already did ride requested. Okay, this event gonna consumed from the Kafka topic, that is ride requested, and published by ride service, when a rider requests a ride. Okay, fine. So what the fields we need to create? Same private string rider id. Okay, then private string ride id. Okay, let me do fast forward. Fine. So pick up latitude, longitude, address, drop latitude, longitude and address. Okay, now I want you to just comment me down what fields gonna will create in the our another event, ride matched event. Okay, and no args constructor. Okay, fine. So I want you to please let me just write the comments, and then please you comment down in the comment section that what all fields we need to write here. So published to event, published to Kafka topic, and let's say ride dot matched, matched, right, and consumed by ride service to update ride with assigned driver. Yes, yes or no? Yeah, okay, correct. So here private string ride id, okay, and private string rider id. Okay, now also we need to provide the details for driver id. Okay, then private double driver latitude. Okay, same thing, private driver longitude and private double, so distance to pickup. Okay, how much is the distance in kilometers to pickup? That is the field, and let me just copy and paste. Yes, okay, so there are two events, ride matched, ride requested. Okay, so now next I want to ask you something. So in the location service main Java, and in the service location service we have implemented what, one method, that is find nearby drivers. Okay, and we have added one comments like find nearby drivers within given radius called by matching service. That means our matching service, definitely our matching service calls the location service this method find nearby drivers. Okay, to get the nearby drivers, appropriate drivers, okay, proper best driver. Yes or no? Yes, and we are returning the list of this nearby driver response DTO, which contains driver GPS coordinates, okay, and distance in kilometers. Yes, okay, so we need to call from one service to another service a method. The best thing we're gonna use is fain client. Okay, so let's add the dependency. Okay, location service, okay, in the matching service src pom. Let me just go to my browser, mvn repository, just mvn repository, okay, .com. Fine. Okay, here let me just write cloud starter open fain. Okay, yeah, can you see this? So current version, and just copy this spring cloud starter open fain. Okay, also you can just go to that spring initializer. Okay, and here open fain explore, just scroll down, and yeah, this, just copy this. Yes or no? dependency. Okay, so fine, and let me add this dependency, right? Also we need to add the dependency management block. Okay, so here, yeah, this one, dependency management. Okay, after dependencies, so after dependencies, dependency management. Okay, and here I want to be 2023, yes, .0.0. Okay, better for the clean code, let me add here. Okay, so spring cloud and dot version, so it's 2023.0.0. yes, spring cloud version. And here let me just remove it and spring cloud version, yes. Okay, and then just resolving Maven dependency, go on. Let's wait for a few seconds and then we are good to go. Okay, done. This is the location service. Okay, so we need to call this method. Okay, matching service called by matching service. That means let's use the Feign client. We have already added the Feign, open Feign dependency, so let's use it. Let me create what, the client. Okay, interface dot location service client. Okay, add Feign client. Okay, and name, so location service, and URL, so URL is location dot service dot URL. Okay, we'll see this. Fine, so the method, let me location service. Okay, where is my controller? Location service Java controller. Okay, and yeah, get nearby drivers, so you just come here and yeah, so get nearby drivers, right? So I'm returning the list of this. Okay, same thing, list of nearby driver response and get nearby drivers, yes. Okay, then there are three things. Okay, so add request param double latitude, longitude, and double radius. Okay, let me just remove this. Fine, okay, that's it. And here let me add get mapping, right? Get mapping, and what is this? API v1 locations driver nearby, API v1 locations, okay, drivers nearby, yes. Okay, fine, so this is it. Let me just close this. Okay, let's move to the next part. Only one thing remaining, I guess. So event is done, DTO is done, client is done. Yeah, now the implementation, that is service dot, first is the matching service, matching service. Okay, and then second is ride, let's say event consumer. Fine, okay. So here this is the most important and only main thing of our entire video. Here we are going to write the logic for this method match let's say driver for ride, finding the best driver. Yes, like the steps are, we'll ask location service for nearby drivers, that is what we created. Then we will score each driver, okay, based on the distance plus rating simulation. Okay, then we will pick the best scored driver. Okay, and then we will publish the ride matched event to Kafka. Yes, 4 steps. Okay, ready? Let's start. Add first service and add slf4j at required args constructor. Okay, now private final and location, what is that, service client. Okay, location service client, then private final Kafka template, okay, string and ride matched event. Okay, Kafka template. Yes, and then private static, so the topic final string ride matched topic equals ride.matched. Okay, there we have created the Ride.Requested. Okay, private static, okay, and let's create the default radius. Okay, double, so default search radius and in kilometers equals, let's say 5 kilometer, within 5 kilometers. Okay, now our first method, that is public void match driver, and the most important method match driver for ride requested event. Okay, and event. Fine, so let me add the comments. The comments is most important. Okay, main matching algorithm. Okay, it's a main matching algorithm. Fine, and called when ride requested event is consumed. Okay, when it is consumed, like requested by user. Okay, and the steps. Okay, so is steps, the first step is ask location service for nearby drivers. Okay, yeah, so let's do it. So list, okay, let me get the list, and list of nearby driver response. Okay, nearby driver responses, or let me just nearby drivers equals location service client dot get. Okay, so in this, you know, we have created this. Okay, and it is calling our location service. Fine, and event dot get pickup latitude. Then event dot get pickup longitude and the default search radius in kilometers. Okay, done. Now let me just check it if nearby drivers dot is empty. Okay, if it is coming as empty, then log dot warning, no drivers found near ride. Okay, so yeah, that's it. We'll try it again and then return, simple return. Okay, now if found, then comes our step number 2. Okay, that is score each driver and pick the best one. Okay, let me also just add the step here. Okay, yeah, so now let me take the optional of nearby driver response and the best driver. Okay, so let me create a method. Okay, we'll create this method find best driver. We'll implement the logic and let me pass the nearby drivers. Okay, yeah, the list. Fine. Okay, so we'll create this method. Fine, and then let's move the next. If the best driver dot is empty, okay, it is coming as empty, then same thing, warning that could not, oh, okay, could not find suitable driver for ride. Okay, that's it. Fine, and then return. Yes. Okay, now if, yeah, we got it, then nearby driver response and assigned driver equals the best driver dot get. Okay, because we have used the optional, so after applying get, we will get the actual, the driver, assigned driver. Okay, it is a method. Fine, then here comes our step number 3. That is, what else is remaining? Publish ride matched event to Kafka. Okay, so ride matched event and matched event equals new ride matched event. Okay, so event dot get ride ID, then event dot get rider ID, then comma, and then assigned driver. Okay, assigned driver dot get driver ID. Okay, let me just go to my, oh fine, at data, at no args, and at all args. Fine, now again back to this and dot get driver ID, then assigned driver dot get latitude, then dot get longitude and get distance in kilometers. Fine, now let's send it. So Kafka template dot send and the topic ride matched topic. Okay, and event dot get ride ID. Fine, also let me just add some loggings that ride matched event published. Okay, yeah, fine. Now another important thing, that what is the logic behind finding best driver. Okay, yeah, like how we will score them. So private, optional, okay, and yeah, we're returning the optional, and find best driver, and what we are getting, so list of nearby response driver. Yes, drivers. Okay, so now let me just add the comments. Okay, like driver scoring algorithm. Yeah, so now I want all of your focus to be here, scoring algorithm. Fine, and we are going to consider the weightage on distance and rating. Yes, see, once you understand this, then you'll able to build any of the ride sharing platform with more factors. Like in production, there is also a factor of acceptance rate. Okay, acceptance rate. Fine, number of completed trips. Okay, driver tier, and etc. So the score, first let me also mention what factor we are considering. So first is the distance. Okay, yeah, and 70% of weightage, and the second is the rating. Once you get it, you can add so many factors, just divide it, and it has 30% of weightage. Okay, so 70, 30, 100. Now score, so the driver which is more nearest to the rider gets higher. Okay, so that means when the distance is less, okay, this is my rider and this is my driver. So when the distance is less, that means we need to get the more score. If the driver is here, D0, that means this D0 will be on the higher score. Okay, less high, that means inverse proportional. So we need to just add 1 by 1 by, okay, so the score, 1 second, fine, the score equals, let me just 1 upon distance. Okay, that is why, like if a distance, if suppose D0 is on 0.5 kilometers, just 0.5 kilometers, so 1 upon 0.5 equals 2. Score is 2, higher scores, because this D0 is more nearest. And if D1, so D1 is, let's say, 1 kilometer, so 1 of 1, 1, low score. Yeah, so let me, if you want to take screenshot, then you can just take it. Okay, let me just remove it, and then, so this is what our score times distance weight. Okay, so let me declare those two variables also. Double distance weight equals, so distance we have consider 70%, right? So 0.7, yes, and double rating weight as 30%. Okay, so 0.3. Okay, fine. Now what? So times distance weight plus this is done. Okay, plus rating times rating weight. Okay, so this is what our score formula will calculate it. Yes or no? Okay, so then return and drivers dot stream. Okay, and then dot max, so we need to just add the comparator sorting comparator, okay, dot comparing double, okay, and driver. Fine. So here let me just write comment distance score closer, okay, that means higher score. Also if suppose distance is 0.0, that means 1 by 0 not defined. So for that we will add some 0.1, okay, to avoid division by 0, okay. So double distance score equals whatever formula we have written here, okay, 1.0 by driver dot get distance in kilometers plus 0.1, okay, plus 0.1 to avoid what, division by 0, okay. Okay, see, this is the distance score, this part, this is the entire part distance, okay, fine. And then later on we will just multiply it with distance weight. So the first part is done. Now the second part, rating. So we haven't created any fields or anything for the rating. So for now let me just simulate. So simulated rating, let's say between 4.0 and 5.0, okay. But in production, so in production fetch from driver service, okay, definitely. So double simulated rating equals let's say so between 4 to 5, so 4.0 plus anything math dot random, okay. Getting it, like what I'm doing? Yes, definitely. I'm explaining each and every step. So final weighted score is return, okay, return the distance score, okay, distance score times distance weight. So distance score times this weight 70%, 0.7, okay, and plus rating times rating weight. So plus simulated rating times what, oh, simulated rating times rating weight, okay. Yes or no? Yes, whatever I just explained you, whatever the formula we have created, okay, this is the best formula. And then if further you wanna add more factors, like also the score dependent on acceptance rate, completed trips, driver tier, so just get the weightage like 50% distance, 10% rating, 20% that, 20% that, and implement this. Yes or no? Simple? Yes, it looks, yeah, easy, and it is okay. So completed. Yes, done. Everything is done. Everything is absolutely done. Now only one thing remaining, that is what, resources, application.properties. Let's do it quickly. Let me just delete it and let me recreate my application.yml. Right, so first application properties, spring dot application dot name, which is matching service, okay, and server port, so 8084, okay. Then Kafka consumer properties, So spring dot Kafka dot bootstrap servers. Okay, so it's local host and 9092. Yes. Then spring dot Kafka dot consumer dot group id. Okay, so it's like what, matching service group. Okay, spring dot Kafka dot consumer dot auto offset reset. Okay, which is earliest. Okay, then key deserializer. Okay, and value deserializer. So Kafka dot consumer dot key deserializer. Okay, and so it's what, let me just copy and paste from the right service, main resources, and yeah, this org dot apache Kafka command serialization string serializer. Okay, and now here it is key deserializer, right? So where is that deserializer? Okay, yes or no? Same thing, value, it is serializer, so value deserializer and JSON deserializer. Oh, I remember just one thing, one more matching service application. Okay, so here we use the fain, so enable fain client, not schedule, enable fain clients. Okay, yeah, let's continue. Then the properties for Kafka producer. Okay, so spring dot Kafka dot producer dot key serializer. Okay, key serializer producer dot key serializer org apache Kafka command serialization string serialization and value serializer. Okay, so org spring framework Kafka support serializer JSON. Fine. Now the properties for location service URL. Okay, we are using fain client, so we used this location service URL. Let me just copy this. Okay, location service URL, and it is http localhost 8082, right? And now the last is actuator, so same thing, management dot endpoints dot web dot exposure dot include health info. Yes, yeah, done. Everything is done. Everything is absolutely completed. So this is what our first project, and let's start learning and building great. Okay, yeah, so see, this is what the complete entire. Okay, we need to add the payment service and pricing, then rating, trip, driver onboarding, support service. Okay, but the base is this only. This is what the base. Okay, I told you, like, you can implement now at your own. If you haven't, you can just comment me down, or you can just join our WhatsApp community. Okay, the link is given in the description. Okay, so we have a community of the great developers. Okay, and around 500 plus. Okay, so you can just ask there and I'll definitely respond you back. Okay, yeah, so back to our project. Before testing, let me first check all the files. Okay, location service, and config controller, okay, DTO and service. Yeah, then matching service client, okay, nearby find, and in the service right. Okay, so we haven't coded right event consumer, the most important part, like how our matching service will consume, the most important, section part. So let's start at service, okay, and at required args constructor, okay, we need, then private final, not this, private final, and matching service, yes. Now let me add the comments, important thing. So it does, what it does is it listens to Ride.Requested, the Kafka topic we created, Kafka topic, okay, and triggered every time ride service publishes a new ride request. Yes, so if a user every time request a new ride, so it triggers, because our matching service needs to consume that event. Yes or no? Okay, so let me also show you the flow. So ride service first, and then Kafka, and ride dot requested, okay, then this consumer, okay, and then matching service, okay, fine. So now public void, and let's say consume ride requested event, okay, and I'm getting the ride requested event and event, okay. So let me just open my try catch, okay, and in the try matching service dot match driver for ride, and let me pass the event, okay. In the exception, let me just log dot, okay, so for that at slf4j, and error processing ride request, okay. uh, so then we'll write event dot get ride id and e dot get message. No, it's fine, okay, fine. And also in the production, like send to dead letter queue for retry, okay. So also let me just write that in comment in the production, send to dead letter queue for retry, okay. It's done, yeah, it's done, completed. Yeah, one more thing, the most important annotation, Kafka listener and topics, so ride dot requested, okay, and group id, so group id is matching, and what's the group id, matching service group, yes, okay, it's done. Now let's start. First let me start my, all the data flow, that is Redis, MySQL already running the backend, okay, and Zookeeper, Kafka, okay. So let me just open my Docker. So here are my, Redis Geo and Kafka and Zookeeper. So let me just start, and also Uber app, which will start both of my Kafka and Zookeeper, and MySQL is already running in the backend. Okay, I already installed in the my local. Okay, so now let me just run the application one by one. Run. Okay, fine. So let it run. Let's wait for few seconds. Okay, and yeah, on the port 8082, and started the local location service application. Okay, now let me start my Ride service. Okay, so make sure you have in the application.yml you have added your proper that MySQL password. Let me just run Ride service application. Yeah, let's wait for a few more seconds to let it start. Okay, so we are getting some error and unknown database. Okay, so we haven't created the database Uber app. Fine, let me just go to my MySQL command line. Okay, installed in the local, and create that. My password, and create database Uber app. I guess there I have created by the wrong name, that is user app. Okay, so create database Uber app created. Again, let me just hit the run. Now I guess it will run. Also one more changes I did, that is in the model ride. Okay, first let it start. Fine, created table rides, and okay, so Kafka version and start time. Yeah, started ride service. So here I've updated the driver ID. Okay, the validation part. So initially it was like I've added this column nullable false here on the driver ID, but it's wrong. Okay, we should have to remove this property. Why? Because see, driver can be null. This is the ride. Okay, so just see here, when my rider, just like let's imagine in a real world. So when we open our Uber app, and this is my rider, and suppose rider requested a new ride. Okay, so then publishers and matching service consume the event. So till then the status is matching. That means our matching service is finding the driver. Till then in this object ride, we have the rider ID, we have the pickup latitude, okay, whatever just user has given everything. But till then, before anyone accept our ride, the driver ID is definitely null. Once driver accepted, then we will update our ride object with the rider ID and this driver ID, like whoever accepted. But till then, before when our status is matching, the rider ID definitely be null. After accepted, so the status change from matching to accepted, and will update the driver ID in our ride object. Yes or no? Yeah, so driver ID can be null. It's wrong to add like a column nullable false here. Otherwise it will give us a big error. Yes, okay. So this is what one thing I observed, and yeah, so this is one issue. Yeah, definitely. So this is what the great part. Once we'll start testing, we'll get to know what we have did wrong. Okay, so this is done, and now our matching service. I hope let's finger crossed. Okay. Yeah, yeah. So like my gut feeling is saying something wrong gonna happen. Okay, let's see. Matching service application. Fine, starting matching service application, and okay, started. Okay, fine, good news. Now let me open my postman. Okay. Yeah, testing part is, the most interesting part. It's like, uh result, exam result. Okay, so whatever mess you did, then get to know in the testing part. Okay, so let me just first the testing flow start. First we need to add the driver. Okay, just remember this thing, you can just note down in your notebook. So let's start. The first thing is uh, keep all the data flow ready. Okay, which we already did. That is our Docker part. It is up and running. Okay, Redis, Kafka, Zookeeper, and MySQL. Second thing is start all the applications. Okay, fine. Third thing is so first we need to add the drivers. First we need to add the drivers. Okay, so here's my postman. Okay, and let me just shift them here. Okay, now the first you know what now the first we need to add the drivers. Okay, so location service Java and controller location update driver location. Fine. API v1 locations and running on the port 8082. Okay, fine then. Localhost 8082 and API, so API v1 locations and drivers update. Okay, body, it is post request raw text JSON, and what I'm requesting. Okay, three things. So driver ID, yeah. Okay, driver ID, that is, let's say, driver 1. Okay, and then latitude, so let's say 12.9716. okay, same latitude longitude, will add longitude, so longitude, so it's 77.5946. okay, yeah. Now let me just hit send, and what I'm expecting, so I'm expecting, okay, driver location updated. Okay, so yeah, driver location updated, done, success, got it. Yeah. Okay, now another, let's say, let me add the three drivers, so driver ID driver 2 and 12 point, let's say 9800 and 77.5800. okay, another driver ID 2 with the different coordinates. Okay, now one more driver 3, the latitude, let's say 9600 and 77.6100, driver 3. Okay, so now let me just check that how many drivers I have added. Okay, so just like we can also check via raw redis command. Okay, so let me just open my bash, git bash. Okay, and just like when we were setting up, so I have shown you everything. First let me just go into the redis, so docker and redis geo is the name, and redis cli, one second, redis cli. okay, so yeah, I'm inside, and the command is z range key drivers geo key drivers locations. Let me copy this. Okay, where is my driver locations and 0 minus 1. Total 3 drivers in my Redis stored. Okay, done. It's done. So everything happens via coding. Okay, so location controller and drivers nearby okay, and so let me also provide what params. Okay, yeah, so params, fine. So latitude equals, let's say 12.9761 okay, and longitude equals 77.5946 okay, and radius, so let's say in 5 kilometers. Okay, get, so I guess, yeah, I got all the 3 drivers. Okay, so all 3 are just nearby only. Okay, expected response, this is what I am expecting. So can you see, uh, I have given in the 5 kilometers of range. So distance in kilometer is this 0.5 kilometer, this is 1.6 kilometer, and this is 2.4 kilometer. So all are in the 5 kilometers of range. Yes or no? Fine. Now we need to get the best driver and assign. Okay, so now this is what the driver part is done. Driver is created and they are moving around our city. Now a user wants to request a ride. Okay, let's go with that part. Where is my controller? Ride controller. Okay, and API v1 rides, API v1 rides. Okay, and fine. So API v1 rides and request also which port, it's 8083 and post request body JSON and see. So okay, one second, I forget to add. Now what? Now the fourth step of testing, that is add the drivers. Done, checked, like we got all the 3 drivers okay from the raw Redis. Okay, also we have checked the nearby okay, nearby drivers okay with their distance in kilometers. Fifth is now user request a ride. Okay, fine. So user request a ride. Okay, you just go down and here controller. Okay, ride request, ride ID, pick up longitude, latitude, drop, and everything else. Okay, fine. So rider ID, rider ID. Okay, rider ID. Okay, let's say rider 1. Okay, and then pick up latitude. Okay, so let's say same thing, 129716. Okay, and pick up longitude, so 775946. okay, and then pickup address. Okay, pickup address. So let's say MG Road and Bangalore. Okay, then same thing, drop latitude. Okay, so let's say 12.9352. okay, and drop longitude, so 77 point, let's say 6245. okay, and the last is drop address. Okay, so let's say anything, KLM mall, let's say whatever, I don't know, Bangalore, right? Okay, KLM mall Bangalore, and then post it. So what it does is ride request, ride request. Okay, so creates a new ride, save ride into database, and then publish event to Kafka. Matching service will consume this event and start finding the nearest driver. Okay, that means, so let me send it. Okay, fine. So created a record in the database, and 1 second, the console is giving me some errors. Okay, 1 second, let me just stop it. Oh, right service stopped. Fine, no worries. So matching service, and first let me, okay, yeah, the error handler cannot process serialization. Okay, and is not in the trusted package. Okay, fine. So I guess one property is missing in our application YML. Got it. We just need to add the trusted packages. Okay, so in my matching service application.yml. Okay, and yeah, here, and we need to provide the path. So consumer group ID, auto offset, reset, key deserializer, value deserializer, and properties, then spring, then JSON, then trusted, then packages. Okay, and what, use type headers false. Okay, and so value default. Okay, and type, it is com dot, so the entire event, and what, ride requested event, com dot ride share. Okay, dot ride requested event. Yeah, now it is, looks good. Okay, matching service, ride requested, and everything looks good. Okay, fine, that's it, nothing we did. Okay, we just added our trusted packages. Fine, and I want you to also just point out one more error, like what I'm thinking. Okay, it's like, you know, okay, we'll see once we'll just go forward. So this is what we did. We have just ran our application, added the drivers, get the nearby drivers. Okay, then request a ride saved in the database, and we got the complete our object. that is ride ID, pickup location, drop location. Okay, and status is currently still matching. Okay, so what I want is, once this is matching, that means once ride is created by the user, immediately consume the event by matching service, and in the console, matching service console, I want few details like, you know, driver details. Okay, but we got an error of trusted packages, so we just resolved it. Again, let me run it. So let me just start my ride service. Okay, fine, it's starting. Okay, started, and the our matching service. Okay, let him start. Okay, started. Okay, ride matched event published. Fine, great. So this is what ride created, and now I need to copy this ride ID. Okay, and one second, how to find that which driver is assigned. So for that also, I guess we have created the endpoints, ride controller, and start ride. No, not that. Yeah, this one, get rides by rider, get rides by ID, this one. Okay, so we'll just pass the ride ID. Okay, let's do it. Okay, so let me just copy this, and v1 rides, and here let me just copy this to ride ID. Okay, need to pass ride ID. Okay, get request, and okay, fine, I'm getting. Okay, yeah, so I'm getting this gut feeling, and it's true, it's damn true. See, with this ride ID, what happens? Okay, I want get ride by ride ID. Okay, I'm getting the complete ride object, but still the status is matching. Like, is still our Uber application is searching. No, right? It's not a, you know, good application, and the driver ID is null. Yeah, why? Because just focus here. The last part, the important part, that a user. This is where our, you know, request a ride. So a user request a ride. Kafka topic ride dot requested. Okay, requested publishes, and our matching service consumes that event. Okay, and start finding the ride. So status is matching, he is finding. Okay, fine, he found, but how my this is the right service, I'm getting this right service object. Matching service job is to just, you know, assign the driver and revert back. But how my right service got to know that okay, driver found? Status is now changed from matching to like, you know, found, driver found. Again, I guess again we need to consume this event, ride matched event. Okay, again our ride service need to consume the event from matching service. Like, okay, found, now get me which driver, get me the driver ID, so that we can show in the UI, phone UI, that okay, yeah, can you see the driver found and he is on the way. So 2 to 3 or more files we need to create. Just need to copy paste, now create. So that is why I just told you, please focus on the testing part, because on the testing part we got to learn so many things. Let me stop all the applications, and quickly in the ride service also we need to get the ride matched. So once the event ride matched event, that means ride is matched. Now this event ride service need to consume to get the driver ID and driver detail, location, and how much distance to pick up. Yeah, in the Uber applications, once driver is assigned, now rider wants to know who is my driver, who is what is the driver ID, location, and how much he is far away from me. So we need to just copy this from the matching service, and in the ride service, in the event, we need to create a Java class, same ride matched event. Paste it here. Done. One more thing. This is what our event and the consumer we need to create, just like we have created this in the matching service. This one, Kafka listener, to listen topic. So now we need to create same thing here, so that our ride service listen back. So ride event consumer, and as service slf4j, and at required argus. So private final ride service and ride service. And then we'll create public void, and so here consume ride matched event. So now ride service again need to consume this, and this is what we created just now, ride matched event. And then fine, you can just add the loggings at your own. Let me just ride service dot update. Yeah, so this is what we have created. Yeah, this one. Can you see? If you remember this one, this method, update ride with driver, and I especially told you while coding this that there is no such method in our controller. By this update ride with driver, no such method. Request ride, get ride, start, complete ride. Then why we are creating this? We are creating because once matching service found the driver, again our ride service consume that event and update, set the driver ID and update the status as accepted. Yeah, accepted, I forget that, accepted. So now need to call that consume, then I'm calling that method. And the event dot get ride ID and event dot get driver ID. Yes, that's it. And at Kafka listener topics, so ride dot matched and group ID, so ride service group. And also we need to just update our YML. So everything looks good till here. Kafka, bootstrap servers, producer, key serializer, value, consumer, group ID, ride service group, auto, offset, reset, earliest, key, value, properties, Spring JSON, trusted packages, and use, type, headers, false, value, default, type. And where is my ride matched event? Need to give this path. event ride matched event dot. Okay, fine, looks good, looks absolutely fab. Now that's it again. Let me start quickly and run all the services. Okay, let me start freshly. Okay, so again let me just okay, fine, leave it. Come on, okay, started. Then let me start my ride service. Let's wait for a few more seconds. Okay, and let me start the or matching service. Fine, started. And okay, go back to the postman. And now can I hit this? Should I hit this? Okay, fine, let me hit this. Can you see this? Now driver ID driver1 assigned, status accepted. Why this happened? So here a user requests a ride with his ID, his coordinates, and he wants the drop location KLM Mall, Bangalore. Okay, once this is done, matching service consumes that event and process and found the driver. Okay, done. Backend then found the driver. Then we got this in return that this ride which is requested by the rider, whose ID is this ride ID. Okay, done, good. Let me also go to the database and use Uber app. Okay, then show tables, I guess only one tables, then select a star from rides. Okay, so here is what our rides, right? Okay, let me just, so this is our ride ID. Okay, and actual fare completed at, and this all the fields. Okay, MG road and whatever. Okay, so this is what ride ID created. Okay, now matching service found already a driver. With that ride ID I want the entire ride with updated. So once he found, now whatever we coded right now, we have in the ride service, in the ride service we created a consumer part, that he will also consume this event, the driver ID, to update this object with the driver ID. Okay, driver location, like, yeah, now I can see the driver location. He is this much far away from me and he accepted my request and he is coming. Yes or no, with actual fare and whatever. And so this is what the process starts. Okay, yes or no, are you with me or not? If you with me, then you can just subscribe my channel. Okay, fine, you can just comment down, subscribe, like and share, whatever. Let's go. Few more testing is pending. Okay, so now this is accepted. Let's start our ride. Okay, for that we have a ride service. Okay, main Java controller, ride controller, and start ride. Okay, so start. Okay, ride ID and start. Fine, this is put mapping and nothing else. Okay, let me send it. So now can you see the status is changed from accepted to ride started. Now my user in the car and ride started. Okay, once ride started, this API hits. See, in the backend it works like that. Okay, fine. So now once ride completed, okay, so fine, you have just done the payment, everything is done, and this endpoint hits. So can you see status ride completed, you reached on your location KLM Mall Bangalore. Okay, and same like cancel, ride cancelled. Okay, we have the status already in the model. All this requested, matching, accepted, driver, arriving, ride started, completed, and cancelled. Okay, so one more thing, if suppose one more endpoint I want to show you in this location service. Yeah, so yeah, when driver goes offline, so we need to remove that driver. Okay, currently can you see three drivers? Again, let me hit this API sorry, command. So we have three drivers moving around in this location 5 kilometers in range. Okay, now when driver goes offline, his shift is over and he goes offline, so we need to remove that driver from like user should not able to see that removed. Okay, so let me hit this API v1 locations localhost 8082, right? Okay, so remove driver, delete, okay, localhost 8082 API v1 locations, yes, and driver ID. Okay, driver ID I need to pass here. So what is the driver ID? Okay, let me check here. Driver ID is this, driver 1. Okay, driver 1, that's it, and send. So I guess driver removed successfully. Okay, so now let me just check it. Yes, can you see driver 1 is removed, he goes offline. Only there are now two drivers visible, they are moving around the city, driver 2 and driver 3. Yes or no? Are you with me? Are you with me? Yes or no? Just comment me down yes. Okay, so this is what our entire backend Uber system. Okay, in this there are few more things we need to add. Okay, but those are just secondary things like payment. Okay, fine, we can add the payment gateways. Okay, so before that you'll get enough confidence when we'll complete our e-commerce application. Okay, in our the microservices series course which we are continuing, and yeah, so the backend is done, all the factors you can consider. Okay, and everything, the flow, HLD architecture, okay, the working and coding I've explained. Okay, so let me just go to my browser. So okay, here Spring Boot microservices full course, and I promised you, I remember that after this course you need nothing, no course, okay, nothing. So master microservices with real projects, and we are in between the e-commerce platform. Okay, so after this beautiful financial year of ending, I just wanna give you some good project. Okay, so that is why I've created the full Uber application. Okay, then after that, now we'll continue our this. So we are on our shop zone application, I guess product service is done, and step 0, okay, cart service and payment service, inventory, so and shipping service. So we need to continue that, and all these technologies. Okay, all these technologies, dockerization, okay, and then everything. See, it comprises of around 300 lectures plus my planning is okay, orchestration, then Helm, Then yeah, project Netflix with 10 microservices, okay, video transcoding, everything else. And then comes what? Our Uber application. Okay, so this will be, you know, bread and butter for you, because you already know everything, okay, the backend thing. So just we need to add few services: notification, payment, pricing, okay, and yeah, matching service done, right service done, okay, user services, you know, same thing, authentication and everything else, and nothing. Okay, it makes, okay, I'll make you easy to understand and code everything else, okay, without my help or anyone in the company itself. Okay,